This is RD Sharma Solution Class 12, Chapter 31. It may be different in your edition. Probability exercise is 31.1. Now compute PA by B if PB equals 0.5 and PA intersection B is 0.32. Now let me tell you the formula first. This is PA by B. It is not divide. If you know the probability of B, what is the probability of A? Is PA by B. This is a conditional probability. So in the numerator, it will always be the intersection of these two sets. That is, if you take intersection of A with B or B with A, it remains the same. In the denominator, it will be always the denominator. That is PA by B. So PB will come. This B, which is below, will always come in the denominator. So there are basically the numbers NA intersection B divided by NB. What is PB here? It's given already 0.5. PA intersection B is also given, which is 0.32. So PA by B will be computed like this. So this will come as 32 divided by 50, and this will be 16 divided by 25. Now please remember that you need to check that the probability has to be between 0 and 1, inclusive of 0 and 1. So 16 by 25 is indeed between 0 and 1 and equivalent to 0 and 1. That is, it lies between these two peripheries. Now this is the formula. Now the next question is PA, PB, PB by A. We have to find PA intersection B and PA by B. I'm not saying PA divided by B or PB divided by A. So this, let's write this formula first. PB by A. That is, the probability of A is known and we need to find the probability of B according to it. This will be, A comes in the denominator, PA. Numerator will be P. A intersection B or B intersection A, it remains the same. So we'll write always PA intersection B in the numerator. PA intersection B, this is what we need to find out here. PA is already known to us, that is 0.4. PB by A is also given in the question, which is 0.5. So let's write it here. Multiply these two, PA intersection B. And this will be 0.5 into 0.4, that is 0.2. Now the second one which is wanted in this question is PA by B. That is, if B probability is known, what is the probability of A? That will again be PA intersection B, and this will come in the denominator PB. So what all we have? PA intersection B, which is 0.2. PB is 0.3. And this is PA by B. So 0.2 by 0.3 is 2 by 3. So this 2 by 3 will be your probability of A when B is known. That's your answer. So the two of the things we have found out. So this is how this will be done. This is the formal way you have to go about in order to solve this. Now in this question, A and B are two events such that PA, the probability of A event is 1 by 3, probability of B event is 1 by 5, and PA union B is 11 by 30. So we have to find out the probability of B if A is known, B if A is known. So A union B, this formula is very important. PA union B is PA plus PB minus PA intersection B. So PA union B is already known, 11 by 30. PA is 1 by 3. PB is 1 by 5. And PA intersection B has to be computed. So PA intersection B will be what? PA intersection B is 1 by 3 plus 1 by 5 minus 11 by 30. So this is very basic mathematics. Let me write the final result of this one, 1 by 6. I hope you'll be able to do this. Now PA by B and PB by A, let's write them together so that you understand that the formulas, how they are being made here. PA intersection B remains in the numerator for both the cases. So PA intersection B in the numerator. The denominator will take the probability of what is known. So PB which is known in this case, and PA in this case. What is PA intersection B? We just found out to be 1 by 6. So let us write it. In the second part also I'm writing the first numerator. How about the denominator? It's given in the question. PB is given in the question, which is 1 by 5. PA is given in the question, which is 1 by 3. Now let's solve it. The denominator of the denominator will go as the numerator. So 5 by 6. Again, this 3 by 6. This will be 1 by 2. So 5 by 6 and 1 by 2 are the result of these questions. Now you need to check that these probabilities lie between 0 and 1, inclusive of 0 and 1. So this is your final result. and this is the final result. This is how you have to go about it. A couple has two children. That is, this is the first one, this is the second one. You can call them as mother and father. Now they have two children. This is the first one, this is the another one. Now there are different permutation which are possible. First of all, find the probability that both the children are males. You have to find the probability that both the children are males and both the children are female when the condition is given in the first case is if it is known that at least one of the children is male. The second one is both the children are females if it is known that the elder child is female. So when the question comes like this, if it is known, given that, all this demands the conditional probability. The conditional probability has to be there. So for that, we have to make, you already know that we may have to make a sample space of all the possibilities. Then we make the different sets for all the possibilities pertaining to the question being asked. See, the sample space will always be made. So the first kid can be male, the second can also be a male. Both are males. The first can be male, another one can be a female. The first one can be a female, the other one can be a male. Both kids or children can be female. So if you have two, say, different things, the possibilities can be 2 by 2, that is 4. That's what I'm writing, M1, M2, M1, F2, that is male, 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 female, female, male, and female, female. So this is the bigger set or the whole possible set. Now pertaining to this question, particular question. So first is A. Both the children are female. This is the set. You will wonder why I'm taking A as both children are female. Why I'm not starting with the probability that both the children are males. You'll just see now. A is both the children are female. That is F1, F2. That is the content of this set. Another B, which is the event, is the elder child is a female. So I'm taking according to the question or the answer I perceive. That's why I'm making it like this. B is elder child is a female. Now see here, elder child means the first child should be a female. The other child doesn't matter. So F1, F1, wherever you have the first child as female, the next one can be anything. So F1, M2 and F1, F2 will come. So F1, M2 and F1, F2. This is your B. The next will be set C. At least one of the children is male. So in the sample space, you have to find out that at least one has to be M. Both can also be M. So I'm writing at least one child is male. So you just can't have female, both the females cannot be there. Other all possible combinations or other, say, elements of the event are possible. That is M1, F2, that is one male here. F1, M2, again one male here. And M1, M2, that is both are males here. Then coming to the set D. Both children are males. And then same as both children are female, there is only one element of this set is possible, F1, F2. Similarly, both children are males, that is M1 and M2. This is the only possibility. We cannot have a female in between. Or first or second can be female, both can be female. That is not possible in this case. Now as we have made all these sets, let's come to the question being asked. The first one is, find the probability that both the children are males if it is known that at least one of the children is male. Now what is D and what is C? C is at least one child is a male. That is why we have taken this. So if C is known, that is at least one of the children is male is known, what is the probability of both the children are males? So the first one is P D by C. C is known. If it is known that at least one child is male, what is the probability of D, which is both children are males? This will be P D intersection C divided by P C. And this probability is simply N, the number of elements in this. So D intersection C. So what is the common between D and C? You have already the element, just see which one is common, which is the intersection. So M1, M2 is the only element which is common in both these sets. What is the number of element in D intersection C? M1, M2, that is 1. So P D intersection C is 1. So eventually you have to write the number. So it will be 1. What is C? PC. That is probability of C, number of element in C, which is 3 here, M1, F2, F1, M2 and M1, M2, 1 by 3. Now coming to the second one, which is the probability of A by B. Now if we know that the child is female, find the probability that both are females. That is, you have made the set like this. So PA by B is PA intersection B divided by PB. PA intersection B is what? NA intersection B divided by NB. So what is NA intersection B? Take A and B, find the common values, common elements. F1, F2 is the only common element. So NA intersection B is 1. What is NB? How many elements are there in B? F1, M2 and F1, F2. That is 2. So we have 1 divided by, this is 1 divided by 2. That's your final result. 1 by 3 and 1 by 2. Now this is the whole procedure. It was a good question. You may be able to do it by yourself. So this is all about this exercise. Thank you so much. Have a good one.